I'm sure you've watched dozens of videos about the Big Bang by now. We are familiar with the inflation theory, the Big Bang theory, and the cosmic background radiation, but when it comes to what preceded the Big Bang, we are almost at zero. Are you ready? In this video, we will surpass that point zero. Buckle up, we are going back to before the Big Bang. Before we go back to before the Big Bang, our first stop is black holes. Ton 618, the largest black hole ever discovered in human history, is 10.4 billion light-years away from our world and has a mass about 66 billion times that of our Sun, considering our observational capabilities and the limits of the observable universe. It's not incorrect to say that the largest black hole we have discovered is just the beginning. We must remember that until 1920, we thought the entire universe was the Milky Way galaxy. It wouldn't be surprising if a larger black hole were discovered in the days ahead. To reach before the Big Bang, we first need to look at the definition of black holes from a different perspective. When a gravitational field generates a gravitational force that does not allow objects traveling at the speed of light to escape, we can talk about a black hole. Actually, the threshold for becoming a black hole appears to have been set by the speed of light. Roughly speaking, calculations and observations suggest that a star with less than 20 solar masses cannot turn into a black hole. We see that our universe has set a lower limit rule about becoming a black hole. Is there an upper limit to this in our universe? What could a black hole with 150 billion solar masses do to the fabric of spacetime? For now, let's leave this topic here to return to later. We almost know that the Big Bang started from a singularity, i.e., an infinite energy concentrated at a single point. If you ask where else the concept of singularity appears in the physics world, black holes come to mind. Nearly all physicists agree that the center of black holes is a singularity. However, no one has a detailed idea of what a singularity is. If we simplify it, we can understand that 66 billion solar masses at a single point would infinitely bend spacetime. But how much mass can the fabric of spacetime tolerate concentrated at a single point? Is there a limit to this? Unfortunately, we don't have an answer to this either. Moving from the fact that our universe likes limits, both in the speed of light and in creating black holes, there's no harm in continuing with a simple analogy. Let's think of videos on all social media where objects are bent and compressed under pressure. Just like in these videos, there's a limit to resistance against pressure in every possibility. So, saying that black holes might eventually tear space-time, although we can't prove it, it is within the realm of possibility. For the sake of simplification, I risk being viciously criticized in the comments for describing it as a tear. Another similarity between black holes and the moment of the Big Bang is the issue of the speed of light. To date, the first event we suspect surpassed the speed of light was the faster-than-light expansion during the universe's inflation period. Is there a situation where the speed of light is exceeded now? Even if you travel at the speed of light, you cannot escape from a black hole, meaning the gravitational force of a black hole is greater than the escape force of an object traveling at the speed of light. Saying that black holes create at least a gravitational force above the level of the speed of light wouldn't be incorrect. Summarizing the topics we've discussed so far, extraordinary events like surpassing the speed of light and singularities in the Big Bang theory seem to exist both during the Big Bang and in black holes. If we combine these incredible similarities with the fact that our universe likes limits, could it be possible that our universe was born from a black hole? Theoretical physicists like Lee Smolin and Nikodem Poplawski have worked on speculative theories that our universe was born from a black hole or that we are inside a black hole. Those interested can study these theories. Let's save Lee Smolin's theory for another video. Using these two theories to speculatively explain the process leading to the Big Bang, could it be possible that a black hole reaching a certain mass eventually surpasses the limit of the space-time fabric to hold this incredible mass and tears it apart? Assuming this scenario is real, this megamassive black hole containing all this energy could have started a new universe with an outburst similar to the Big Bang. Expanding this theory further, every mega-high-mass black hole in our universe could one day tear space-time to create a new universe, making each universe a source of millions of universes. Even if this situation were proven experimentally, the question of where the first universe that spawned other universes came from would arise. But let's leave that for another video. Thank you, science lovers, for watching our video.